Welcome to myprojectbazaar.com. Now we discuss about the product detecting salient objects via color and texture compactness hypothesis. Now we discuss the abstract for the process. In recent years, the object level saliency detection has attached much recent attention due to its usefulness in many high-level tasks. Existing methods are mostly based on the contrast hypothesis, which regards the regions with the high contrast in the certain context as salient objects. Although the contrast hypothesis is effective in many scenarios, it cannot handle some difficult cases. As a remedy to address the weakness of the contrast hypothesis, we propose a novel compactness hypothesis which assumes salient regions are more compact than background from the perspective of both color layout and texture layout. Based on the compactness hypothesis, we implement an effective object level salience detection method. In the proposed method, we first construct a weak saliency map based on the contact hypothesis, then collect samples from the weak saliency map to train a dedicated classifier. This classifier is applied on each individual pixels of the input image to produce a difference score. Finally, the confidence score are used to form a saliency map. This process is carried out at different scales and the corresponding results are integrated into the formation of the final saliency map. The proposed approach is evaluated on some benchmark datasets and then it is well efficient to segment the region. Now we discuss the flow diagram for the process. This is the overall flow diagram for the process. At first, the input image is taken from the dataset. The dataset is the folder which consists of the several dataset images. Here I have attached the sum of the sample dataset images. Select any one image from the dataset. After selecting the image from the dataset, the superpixel segmentation is carried out for the initial image. The superpixel segmentation result will be like this. After getting the superpixel segmentation result, the color transformation is done. In the color transformation, the image is transferred into a lab color transformation. The LAB image is obtained from the color transformation image. From this color transformation, we have to segment the image. In the segmentation process, we have to consider the three types of segmentation, that is the quasi segmentation, then by the classification segmentation, then by the refined segmentation. In the quasi segmentation, the initial segmentation will be carried out and by using the classification, the segmentation result will be once again refined. Then the final refined segmentation is the final segmentation as well as the saliency is applied to that only. Then the final estimation is carried out for the segmentation result. The estimation like the precision recalled will be estimation for the segmented result. If the result is more accurate, means the precision will be more. Now we discuss the initial running procedure for the process. At first open the MATLAB 2013 and change the current directory. Now you can see the main_GUI.m. If you want to execute this file, right click in that file and click the option run. Now the initial GUI design was opened. In that you can see the several push buttons in the left side and the two axes in the right side to display the image. Now click the button input image. After clicking the button input image, just open the folder and datasets and you can see the several dataset images present in this folder. Select any one image from this folder and click the button open. After clicking the button open, the selected image is shown in the axis 1 with the title input image. Now click the button multi-scale superpixel segmentation. After clicking the button multi-scale superpixel segmentation, it will take some more time to the segmentation process. Now the SLIC segmentation result is shown in the axis 2 with the title SLIC image. Now the segmented images with the respect to the edge regions are shown in the figure 2. Now click the button lab color. After clicking the button lab color, you can separate the L, A, B channel from the image. Now the L image is shown in the axis 1. Now the A image is shown in the axis 1. Now the B image is shown in the axis 1. Now the lab image is shown in the axis 1 with the title lab image. After the lab conversion, the queer saliency is considered. When the queer saliency button is clicked, the iteration is run for the 256 iteration corresponding to the size of the image. It will take some more time to the execute. After the execution, the queer saliency map region is shown in the axis 2. Now the queer segmentation region is shown in the axis 2 with the title queer segmentation. Now this is the figure for the queer segmentation. Here the segmented results are not accurate. Some of the regions in the backgrounds are also taken by this segmentation method. Then click the button classifier. After clicking the button classifier, the classifier result will be undergone and then the classified labels are shown in the background process. Now click the button refine saliency. After clicking the button refine saliency, the refined region for the background and the foreground extraction will be undergone. Now the background is extracted and the exact region of interest is marked as an edge region. Now the performance window was opened. In that you can calculate the accuracy, sensitivity and specificity of the process. Click the button accuracy. Now the accuracy of the overall process is somewhat the 0.96, that is the 96%. Now the sensitivity and specificity value are also displayed in the LED box, as well as the corresponding graphs are shown in the axis. Now the accuracy values are nearly 96 is shown in the graph, and as well as the sensitivity and specificity values are also plotted in the graph format. Thanks for watching this video.